Welcome back to learning program Cisco Networking with Rajput. Today we are going to have a look at BGP best path selection manipulation. There are certain parameters which we can use to influence BGP's best path selection process. And for outgoing traffic, we have two parameters, that is weight and local preference. And for incoming traffic, we have AS path and MED, that is multi-exit discriminator. So we can use weight and local preference for outgoing traffic and AS path and MED for incoming traffic. As we discussed earlier in the video BGP best path selection method, weight is Cisco proprietary, it's a local to router, and higher is better. In the same way, local preference is local to AS, higher is better, used for outgoing traffic. So let us go to live devices and see the manipulation. So this is the network design we have. We have router 1 and router 2 working as mission critical site. Both router 1 and 2 are backing each other, and router 3, 4, 5 and 6 are representing ISP domain. Router 7 and 8 are working as remote sites. I just want to check the BGP table for router 8's advertisement. I'm getting this prefix from router 4, router 3 and router 2, but router 3 is selected as the best path. So currently traffic must be going via router 3. Let us do a trace 8 source loopback 1. So right now the traffic goes from R1 to R3, then to R6, then to finally to R8. I want to use R4 as the best path instead of R3. So weight is the parameter I'm going to use. There are two methods I can apply weight. One is I go in BGP process and call the weight or apply weight directly on the neighbor. So all the updates from that particular neighbor will be having default weight. So that is like router BGP neighbor 14.1.4 weight, let us say 200. That's it. So the another method is I need to create a route map, then set the weight over there and then call that route map with the neighbor. So there are two ways I can apply weight. One, I can directly apply weight on the neighbor. Another one, apply the weight in the route map and then call that route map with the neighbor. So let us check the BGP table. I need to do hard reset. Right now I'm working in lab environment, that's why I did hard reset. And another reason, I have not configured BGP for soft reconfiguration. That's why I need to do the hard reset. But in production environment, you should always make sure that the users are not impacted. So you should make changes in maintenance window only. So let us see what BGP table says. Okay, now for 8.8.8, router 1 applies weight of 200. So let us do a trace now. Now instead of earlier the traffic was going from R1 to R3, then R6 and then R8. Now the traffic goes from R1 to R4, then to R6 and then to R8. So this is how we can use wait for outgoing traffic to manipulate the outgoing traffic. But wait is Cisco proprietary. It can be used only on Cisco devices. And the another important thing is it is local to router. We can use wait only on one router. So over here on router 1 we had two outgoing interfaces, two eBGP connections. So that's why we used wait. So next parameter is local preference. And before that, before we start using local preference, let me remove the configuration we just did so that we have default BGP bash path selection process. BGP for router 4 is not yet converged. Let us give some time. It's done now. R3 is best. Okay, just for sake. Yeah. Okay. Now what I'm going to do, I am going to use local preference, and what I will do, I will make router 2 as the primary router. So any traffic which goes out of AS12 must go via router 2 only. So for that, what I will do, I go to router 2. I first need to create route map local, set local preference as 200, exit, router BGP 12, neighbor, and it is 24 dot 1 dot or route map local pref and in direction. See, there is a really important thing. I'm going to apply a route map in the in direction because any update coming from router 4 that is coming into router 2. So I need to apply the route map in the in direction. I can use it in out direction as well. Like if I need to apply the same route map in the with router 1, then I need to apply it in out direction because now the update is leaving router 2 and going to router 1. So that will be out direction, and when I apply to the neighbor with router 4, I need to apply it in direction. So okay. "24 not yet receiving." Let us give some time. Still not. Okay. To show IPBGP. We have set the local preference of 200, and now if I go and trace from router 1, it should go to router 2, then to ISP domain and further. Yeah, that's it. Now the router 1's traffic goes to router 2, that is from here to router 2, and then goes to router 4, and then goes to router 6, and finally goes to router 8. So this is how we can use local preference for outgoing traffic. So the important thing over here is local preference is local to the AS. If you remember, I applied the local preference in the in direction of a neighbor between router 2 and router 4. So the same update which the local preference we set as 200 was updated to router 1 as well, and the router 1's routing was influenced with the help of local preference. So local preference is local to the AS. Whatever it is set on one neighbor, it will be communicated within the complete AS. From ISP perspective, ISPs can use it differently as well. Like in this case, we have two routers, router 1, router 2, connecting to ISP domain, and if the responsibility to select the primary, one of the connection as primary and another one as secondary is given to ISP, then ISP can use local preference to define one connection as primary and another one as secondary. Let us go and check the how we can do that. Before that, let me remove the configuration we did on this router. No, no route map. Okay, let us go to, let us see the default behavior to show IP BGP summary begin neighbor. Okay, to show IP BGP. It is learning from router 4, that is best, and also learning from router 1, that is internal. So before we go and make some changes in ISP domain, let us first check what is the path router 8 takes to reach the interconnection between router 1 and router 2. Let us check the routing for this prefix. Okay, it is learning. So let us do trace source loopback 8. So the traffic goes from router 8 to router 6, then to router 3, and then to router 1. So if we need to change it and make the router 2 as the preferred path over router 1, we can do that. Like, let us go to router 4, conf t, okay, route map, local pref, set local preference as 200, exit, router BGP 3456, neighbor is 24, to route map, and it will be in direction. Okay, let us do a trace once again. Now we see the change. Earlier it was going to router 6, then to router 3, and then to router 1. Now it goes to router 6, then router 4, then router 2, and then to router 1. So this is how ISPs can define which connection will be the primary and which connection will work as the backup. So this is all about BGP best path selection manipulation for outgoing traffic. In the next video, we will discuss how we can manipulate the incoming traffic. If you find my video informative, please don't forget to like, share and subscribe. Thank you for watching. Hope to see you again.